Hello everyone. In this video, we will solve together the free responses of subtopic 2.4, which is how fast. Now jumping to the free responses. Firstly, fill in the blanks the speed and direction of an object at a particular instant. At a particular instant and the speed and direction, this gives me that speed and direction, they give me velocity, and at a certain instant, this means I mean the instantaneous velocity. However, what is the ratio, which means the division or the fraction, of the change in position, which means the displacement, to the time interval during which the change occurred, is the, so basically it is the ratio of displacement over time. This means we're talking about the average velocity. Finally, what is the absolute value of the slope on a position time graph? So this is the slope, means the average, and the absolute value is actually the speed. So it is average speed. Question number 2. The graph below describes the motion of a ship drifting slowly through calm waters. The positive x direction along the vertical axis is defined to be the south. Here. What is the average velocity? So when I'm talking about the average velocity, this means I need to find the slope. For that, I will choose 2 points on this graph. The average velocity is the slope, which means y2 minus y1 over x2 minus x1, taking, let's say here, x1, y1, which are 3 and negative 1, and the other point here is 0, 0, x2, y2. So y1 or y2 is 0 minus y1, which was negative 1, so minus negative 1 over x2, 0 minus x1, which is a 3, so I'll have negative 1 over 3 or negative 0.33 meters per second. However, the ship's average speed, it comes here as follows. It should be the absolute value, so S average, which means the average speed, it's actually the absolute value of the average velocity, which is the absolute value of negative 0.33. Here it is 0.33, also the same unit. Question number 3. Refer to the diagram below to answer the questions. Find delta t, the time interval, for the change in position from x equals to 5 to x equals 15. So I don't need the displacement, I need the change in time from x equals to 5 to x equals to x equals to 5. Its corresponding time is 2, and x equals to 15. The time is 6. So that time corresponding to this displacement is actually 6 minus 2, which is 4 seconds. The following question, find delta x for the time interval from 2 to 8. Now I need to find delta x, the displacement from the time equals to 2, which is this one, and the position for the time 8 seconds, which is 20. So the displacement is the final position minus the initial position, which is 20 minus 5, which is 15 meters. What is the slope of this line? The slope of this line is the average velocity, which is, I will find it. I will choose 2 points. Let's say this one and that one. The first one has 2, 5 coordinates, and the second one has 6, 15. You can choose any 2 points. It will give you the same value of the slope. So applying the change in rise over run, the change in y over change in x. So 15 minus 5 over 6 minus 2, 10 over 4, 2.5. 2.5 meters per second. Delta y is in meters, delta x is in seconds. What does the absolute value of the slope of this line represent? Certainly here it is the average speed. So S, the absolute value of V average, is nothing else than the speed, the average speed. What is the speed of this object? So basically the speed is the absolute value of 2.5, which is 2.5. If the object continues at the same speed, how long means how long would it take this object to reach a position x equals to 150. So applying the equation here, that V average equals to the position, the displacement over the time, given the velocity, given the time, given the displacement here. How long means, let me find the time needed. So delta t equals to 150 over 2.5, which will give me 60 seconds. The following question, if this object continues at the same speed, how far means find the displacement or the distance will it have traveled when the time equals to 200. Also, given the velocity, the average, which is the displacement over time, given the same velocity, I need to find delta x over 200. So delta x is nothing else than 200 by 2.5, which is 500 meters. Lastly, what formula would you use to determine the position of this object if it had an initial position vector and then traveled at a fixed velocity for a certain amount of time? So the equation of motion is x at any time equals to the average velocity by the time plus the initial position. How far now will this object have traveled if it had an initial position of 220? Now applying it here, and traveled at a speed of 2.5 for 48 seconds. So given here the initial position and the average velocity and the time. Now finding the position by applying the equation of motion multiplied by the time plus x initial will give me 2.5 times 48 and the initial position 220, so the answer is 340 meters. Question number 3. The equation of motion for a person riding a bicycle is x equals to 6 plus 5t. So let me write it again without the unit. X equals to 6 plus 5t. Where is the bike at 2 seconds? Where means let us find x given the time equals to 2. So simply replace everything by its value. X equals to 6 plus 5 times 2, which will give me 16 meters. Second, part B, at what time is the bike at the location X equals to 26? Now here, given X equals to 26, at what time I need to find the time? So X equals to 6 plus 5t. I replace X by 26, leaving the time is the unknown. After computing, I will have 26 minus 6 equals to 5t. 20 is 5t. T equals to 4 seconds. Question number 4. The graph below shows how the position of an object is changing with time. From the graph, identify if the object is moving toward or away from the origin the first 4 seconds. Eventually, during the first 4 seconds, I can see that the object started at 20, later he came into 15 and coming to 10 and finally going to the origin. So basically during the first 4 seconds he's moving towards the origin. Next, what is the object's average velocity at 4 seconds? At 4 seconds, this means I need the instantaneous. Here the instantaneous and the average are the same because we're having the same slope. So basically I will find the slope choosing 2 points. I will choose this one for 0 and 0 with 20. The slope 0 minus 20 over 4 minus 0, which is a negative 5 meters per second. What is the object's average speed in the last 1 second? Eventually, this graph shows the same slope everywhere. So there's nothing different between the velocity at any point. However, the speed is given to be the absolute value of the velocity, which is the absolute value of negative 5. Here it is 5 meters per second. What is the y-intercept? Where is the graph touching the y-axis? It is at 20 equals to 20 meters. Use your answers from part B and part D to find the position of the object after 10 seconds. Now here it is crucial to rewrite the equation of motion, which is Vt plus x initial Now the velocity is -5. The time given here to be 10 seconds. The initial position was 20 meters. This is the y-intercept. So -50 plus 30 plus 20 will give me -30 meters. Here, in question number 5, the diagram below shows the position time graph for a particle moving in a straight line. In which of the time intervals below is the velocity of the particle negative? So where do I have a negative velocity, a negative slope? Actually, I have it all along this line. So yes, I may have more than one answer. So it's actually during this time interval and that one. So it's between 2 to 4 and 4 to 5. Not only the first one. Later, find the instantaneous velocity at 4 seconds. So here, I will find the slope. I will take 2 points on the line, here 220, and there 40. Finding the slope, y minus y over x minus x, y minus y, 0 minus 20, and x minus x is 4 minus 2, -20 divided by 2, -10 meters per second. What's the total displacement of the particle? Actually, here I'm solving this. What's the total displacement of the particle? Actually, it's very crucial to recall what is the total displacement. Given the initial position and the final position, I can find the total displacement. The final position finally here is -10, and actually it started at 0. So x final minus x initial, -10 minus 0 will give me -10 meters. Later, find the average velocity of the particle for the interval from 0 to 5. The whole average velocity, applying that it is the total displacement divided by the time. The total displacement here is what I just found, -10 over the time interval equals to 5 minus 0, which is 5. So the average is -2 meters per second. We reached the last question for this lesson. Question number 6. The graph below shows the motion of an object. What is the object's displacement in the first 5 seconds? Displacement is nothing else than the final position minus the initial position. So when it started, this is a position time graph. Here, the position was 2, and after 5 seconds, the object is here with a final position 3. So, x final minus x initial will give me 3 minus 2, so he only went 1 meters. Later, find the average velocity of the object during 10 seconds and 15 seconds. So I need to find the average velocity, here the slope, the average velocity during the time 10 to 15. So the average velocity, also we can use it as displacement over the time. The displacement here, we're gonna change our x initial and x final for another interval of time. So it started up with x initial and finished with x final here, the 1. So the final minus the initial, which is 1 minus 3, over the time interval from 10 to 15. So negative 2 over 5, it will give me negative 0.4 meters per second. What's the average speed? What's the average speed of the object between 10 to 15? Now I can see that he needs the same interval. He's asking for both the average velocity and the average speed. So let me benefit from the fact that the average speed is actually the absolute value of the average velocity, which is here, I just found it, negative 0.4, which is 0.4 meters per second. Later, write the equation of the motion for the final position of the object during the first 5 seconds. For the only first 5 seconds, which means I'm talking about this time interval, x final equals to the velocity multiplied by the time plus x initial. However, x initial, when it first started here at 2, and the velocity, I found it in part, I did not find it, let me find it. The velocity is the displacement, which is 3 minus 2 over 5 minus 0, which is 1 over 5, 0.2. So by replacing these two in their places, x initial and the velocity, I will have a final equation saying that x final equals to v 0.2 multiplied by the time plus x initial was 2. Lastly, for each description, complete the table with the correct time interval. So the object was at rest when the position was the same. I can see that he remained at the same position during this time interval. So it is from 5 seconds to 10 seconds. The object was moving toward the negative direction at its lowest speed. In the negative direction, I can see that he was here moving in the negative direction and there. But he needs to be having the least speed. Least speed means the least slope. So which one has the least slope? Yes, this one. It is less steep. So from 15 seconds to 20 seconds. The object was moving at a constant speed toward the positive direction. So this means with a positive slope, which means the first time interval from 0 seconds to 5 seconds. Best of luck!